All right, in this lesson, we're going to take a look at factoring using decomposition. So, first thing, if I FOIL this out, if I said that I had 2x plus 1 times 3x plus 4, I multiply the first terms, I multiply the outside terms, I multiply the inside terms, and then I'm going to multiply the last terms. And I'm going to get 6x squared plus 11x plus 4. In the second case, I would do the same thing. 3x and 4x is going to give me 12x squared. The 3x and 3 is going to give me 9x. Negative 2x and 4 is going to give me negative 8x. So I'm left with positive 1x. And then negative 2 and 3 minus 6. If these binomials multiply to make these trinomials, then these trinomials, 6x squared plus 11x plus 4, factors down to the binomials, or the 12x squared plus 1x minus 6 will factor to the 3x minus 2 and 4x plus 3. So when we're considering the problem, what are the factors of 2x squared plus 7x plus 6? We need to find two binomial products which will multiply to make this. Now, we all know how the algebra tiles work, where each one of the big ones is going to be an x squared, each one of the rectangles is going to be an x, and the small squares are just ones. In this case, I have 2x squareds, I'm going to have the 7x's, and then I'm going to have the 6 individual ones. If I arrange the algebra tiles so that the x squareds are on the top left, I have the small squares on the bottom right, and then I fill in with the x's in order to make a perfect rectangle. Then the side lengths up here, where I have a long side, which is an x, and I have two small sides, which is going to be positive 2, or the 2x's here, and then the positive 3. The dimensions are going to give me what the actual factored form is. In this case, I have a length of 2x plus 3. I have a width of x plus 2, which means that the factored form is going to be 2x squared plus 7x plus 6 will factor down into 2x plus 3 times x plus 2. If I'm doing the same thing with 5x squareds plus 7x plus 2, then I'm going to follow the same process. I would take my 5x squareds, the only way I can arrange them is in a long row. I'm going to take my two individual tiles, and then I'm going to fill in my x's onto the other sides. And when I do this, I have a side length up on the top, where this is 5 long ones, or 5x's, and then 2 small ones, and the other side is an x and a singular small one. This is going to factor into 5x plus 2 and x plus 1. When we're doing the decomposition method, so in the beginning, we factored 6x squared plus 3x plus 8x plus 4, or 6x squared plus 11x plus 4 to get the binomial. In order to factor this, we need to split the middle term, the 11x, into the 3x and the 8x so that we can factor by grouping. How do we know to split the 11x into the 3x and 8x rather than 2x and 9x or 5x and 6x? Well, when I'm doing the 3x and 8x, they need to multiply to the same thing as the 6 and 4. So if I multiply the outside terms, 6 and 4, I'm going to get 24. If I multiply the inside terms, 3 and 8, I also get 24. In order to make this work, it needs to group in the same way as A times C. So the two middle terms that we split it up into have to have the same product as A times C. The same thing is true here. If I take the 12 and negative 6, then I'm going to get negative 72. If I take the 9 and negative 8, I'm going to get negative 72. And they still combine together to make the positive 1. So, when we're splitting up, the first thing I'm going to say is I'm going to take the A and C and I'm going to multiply them. And I'm going to get 12. I need two factors of A and C, or two factors of 12, that add up to 7. Well, if I take 3 times 4, I get 12, and 3 plus 4 is going to give me 7 when I combine them. That's what I'm splitting this up into. I'm going to say I have 2x squared plus 3x plus 4x plus 6. Then I'm going to do the same factoring by grouping that we were doing before. I'm going to divide from the first two, divide from the second two. In this case, all I can pull out is a x, and I get 2x plus 3. In the second case, I can divide by positive 2, and I get 2x plus 3. And conveniently enough, what's in the brackets matches. I can say that this is going to be 2x plus 3 times x plus 2. Same thing over here. 5 times 2 is going to give me 10. Two factors of 10 that add up to 7 are going to be 2 and 5. 2 times 5 is 10, 2 plus 5 is 7. So I'm going to split this up, and I'm going to say I have 5x squared plus 2x plus 5x plus 2. Common factor from the first set is going to be x, and I have 5x plus 2. Doesn't look like there's a common factor in the second set, so I'm going to say plus 1, and it's still 5x plus 2. What I factored is the same, so I'm going to take what's inside the brackets, 5x plus 2, and what's outside the brackets, x plus 1. And conveniently enough, both of these match what we got in the other set when we were arranging them by algebra tiles. So, if I continue to factor these using the same method, it should always work the same way. 6 times negative 3 is going to be negative 18. I need two factors of negative 18 that add up to positive 17. Well, that's going to give me negative 1 and positive 18. Multiply to make negative 18, but add up to 17. So I have 6x squared minus x plus 18x minus 3 when I split up that middle term. Factor by grouping, and I'm going to say that I can pull an x out of the first set, and I'm left with 6x minus 1. In the second set, I can divide both of these by 3, and I'm left with 6x minus 1. What's inside my brackets is the same. This is going to give me 6x minus 1 and x plus 3. For example B, 3 times negative 8 is negative 24. Two factors of negative 24 that add up to negative 2 are going to be positive 4 and negative 6. So I split up the middle term, and I'm going to say that 3x squared plus 4x minus 6x minus 8. Group the sets. The first one, all I can pull out is an x, and I'm left with 3x plus 4. And the second set, I'm going to pull out a negative 2, and I'm left with 3x plus 4. What's inside the brackets matches, so it's going to be what's inside the brackets, 3x plus 4, times what's outside the brackets, x minus 2. For example C, same thing. 12 times 1 gives me 12. Two factors of 12 that add up to negative 8. They're both going to be negative, and that's going to be negative 2 and negative 6. So I'm going to split up that middle term and say I have 12t squared minus 2t minus 6t plus 1. I can divide 2t out of the first set, and I get 6t minus 1. And the second set, I'm going to divide out negative 1, and I'm left with 6t minus 1. What's in the brackets are the same, so I can say that this is going to be equivalent to 6t minus 1 and 2t minus 1. All right, when we get to the last examples, well, the first one is already in the wrong order, so I'm going to rearrange this one right from the get-go. I'm going to say that it's the same as negative 2x squared minus 7x plus 15. Always do it in descending order from degree. Negative 2 times 15 is going to give me negative 30. I need two factors of negative 30 that add up to negative 7. And my magic numbers are positive 3 and negative 10. So I'm going to say that negative 2x squared plus 3x minus 10x plus 15. From the first set, I can pull out the negative if I want. It doesn't really matter. So in this case, I'm just going to leave the negative in there and just say that I'm dividing by x. And I'm going to get negative 2x plus 3. In the second set, I'm just going to divide out the 5. And I get negative 2x plus 3. Which means that this would give me negative 2x plus 3 and x plus 5. In the second set, like I said, we always want to deal with the smallest numbers possible. As soon as I see that there's a common factor, I'm going to start by taking that common factor out, 5. And then I'm going to be left with 3x squared plus x minus 2. Much smaller, happier numbers. I still need to remember that the 5 is going to exist. Don't just get rid of the 5. And then I'm going to take the 3 times negative 2, gives me negative 6. I need two factors of negative 6 that add up to positive 1. And my two factors are going to be negative 2 and positive 3. I'm going to split up that middle term and say I have 3x squared minus 2x plus 3x minus 2. Factor it by grouping. And I'm going to take an x out of the first set, and I'm left with 3x minus 2. And the second set is just going to be positive 1. And I have 3x minus 2. And then, like in the other cases, I can see what's inside the brackets matches here. And I'm going to say it's what's inside the brackets, 3x minus 2. What's outside the brackets, x plus 1. And I still have that coefficient of 5 on the outside, that common factor that I pulled out.